Thank you all for being here. My name is Congressman Randy Hultgren, and I am fortunate to be one of the co-chairs of the newly created bipartisan House Science and National Labs Caucus. Many of you are probably familiar with Neil deGrasse Tyson, but for anybody who isn't, he is basically the Chuck Norris of science. Not just a PhD astrophysicist, he's a ballroom dancer with several dozen honorary doctorates, nearly 1 million Twitter followers, all of us politicians are very jealous, and a vest collection that is legendary. His Twitter feed alone is, in my opinion, one of the most fascinating things available on the internet. Ranging from the fact that in 1492 it took 3 months to cross the Atlantic Ocean, but in 2010 it took 15 minutes for the space shuttle to do the same thing, to the more humorous observation that while Mars and the Milky Way and the moon all have candy named after them, no one has yet decided to name food after Uranus. It's not hard to see why Dr. Tyson was named as one of Time magazine's 100 most influential people in the world. Before Dr. Tyson begins, I want to just say a quick word about the Science and National Labs Caucus. Representatives Fatah, Lujan, Nunley, and I founded this bipartisan caucus because all of us are inherently believe that basic research and scientific exploration are embedded in our national DNA. And with pervasive economic uncertainty, it's more important than ever that we reinforce our national commitment to these vital endeavors, because science is a part of the identity of who we are as a nation. We may not know precisely what impacts these activities will have, but we know from past experience that an improved understanding of the universe enhances our lives in ways we can't even imagine. As a people, we strive not only for economic growth, prosperity, and job creation, but also for exploration at both our mental and physical frontiers, pushing ourselves against the boundaries of both our capabilities and our understanding. With a pedigree spanning a half-century, it is self-evident that basic research drives our understanding of the universe, and from that understanding, the payoffs are incalculably high, which is why science-driven technology has accounted for more than 50% of the economic growth of the U.S. economy during the last half-century. But science is an ecosystem, and we must not pollute it with political expediency, because this will always come at the expense of fundamental, long-term scientific research in which this nation needs to invest. So I hope that members of Congress and their staff here today take a look at our new caucus, because it's time for a cultural change here in Congress with respect to the understanding and appreciating the role that science plays in our quality of life, and that change is what we hope to accomplish in the caucus. I'll quickly wrap up by noting that over in the Rayburn building, there is a line from Proverbs engraved on the wall in the Science, Space, and Technology Committee, and it says, "Where there is no vision, the people perish." And while that seems hyperbolic, I think in terms of the American spirit, it becomes exceptionally true. And there is no person in this country better able to inspire a vision than the astrophysicist, Dr. Neil deGrasse Tyson. So please join me in this bipartisan co-chair of the Science and National Labs Caucus in welcoming Dr. Neil deGrasse Tyson.
Thank you. No, I just like messing with the sound guy, keeping them awake. So I got to put my gum out. Don't work. Thank you, first for that warm welcome, and all of you to come listen to my cosmic and scientific musings today. I understand there's some voting going on in the House, so I'll try not to take it personally if the members need to leave and vote. But we'll talk about you when you leave, I promise. I want to begin. Can I get a little more volume? I want to begin by talking about a an observation I made about 15 years ago, which changed my life. And it changed my relationship with the public and with government and with agencies. I was minding my own business in the manicured lawns of university land, and I was asked to write a chapter for the Columbia History of the 20th Century. This Columbia University has a publishing arm, and this was to reflect on and interpret events of the 20th century. It was not an accounting of events so much as it was an assessment of what it meant. The reason why I was not their first choice. This is 1996. Their first choice was Carl Sagan. But Carl Sagan had taken ill. He would die a year later. And they came to me next. And these are awesome shoes to fill. Just, what, now I have to write in some way that would match or rival that which you would have gotten from Carl Sagan? So I thought long and hard about this. They wanted me to write about discovery. And I said, okay, I don't know. And I scratched my head, and weeks later, I said, all right, here's what I'm going to do. I'm going to write about the transition from the discovery of places to the discovery of ideas. And that's an important transition in our species, because it used to mean, oh, let's discover a new land. And you'd build a boat, or you'd hike there, or you'd ascend a mountain, navigate the valley, and then you found a new place. That was discovery. Not until the Earth got mapped did the urge to discover take us to another dimension, and it was the dimension of thought. The dimension of thought. So I said to myself, all right, tell me about all the activities that the human species has engaged in its history. Because personally, I want to go to Mars, all right? Well, I'm a little too old, but I want us as a species to go to Mars. That's a side thing I have. You don't have to want to do that too. It's just what I want to do. And I thought to myself, well, that is a place. It's not just an idea, but it's a place plus ideas. There might be life there. We might learn something. There are new discoveries in the new places. So I said, all right, what did people do in the past to engage in expensive projects? Because if we go to Mars, that's going to be expensive. And somebody's going to have to write the check if we did such a thing. Is that even justifiable to do this? Actually, we put the money in the bank and then they write the check. Okay, that's how, we're all family here. That's how that works. All right, so I said, here's what I'm going to do. I'm going to look at all the things humans have done throughout time. Find out what it cost as a fraction of the GDP of the day, and then ask how much does it cost to go to Mars today? And then line that up in the chart and find out what motivated them to do whatever was this other activity, and maybe we can duplicate that in modern times. That's how we would then engage in major funded projects, I thought to myself. So I thought this would easily fill the chapter, talking about ways people were motivated to do great things. I was going to, different chapters on all the different ways people justified it. And here's what I found. There were only 3 motivators in the history of human culture. 3 motivators that drove nations and states to do great things. Great as in large, unforgettably magnificent, or unforgettably devastating. Just an investment of human and financial capital. We can make a list of what would go on that list, of what would be there. So the pyramids, that's big and expensive, and they're still around. The pyramids. By the way, do you know the next thing in human culture that was built that was taller than the pyramids? Eiffel Tower. The Eiffel Tower. What was that, 18, right? 5,000 years later, we figured out how to make something taller. Actually, there was a cathedral in the 1400s, but they didn't quite know how to sustain domes, so it was a short-lived. All right, the pyramids would be on there, the Great Wall of China, the Manhattan Project, the Apollo Project, the Columbus voyages. We'd all agree these are expensive things undertaken by nations. What did they have in common? Only one of three things. The greatest driver of them all is obvious. It's the I don't want to die driver, all right? The war driver. That's where you get the Great Wall of China. That's where you get the Manhattan Project. Time and again, the conduct of our species has demonstrated that if you feel threatened, money flows like rivers to minimize that threat or eradicate it altogether. No matter the project. There's another driver, the promise of economic return. That's how you get the Columbus voyages and Magellan voyages, Lewis and Clark. You get investments where people say, I don't want to die poor. Okay? There's a third driver there's less of today. Less of it today. It was common centuries ago, and that's the praise of royalty or deity. That got you the cathedral building in Europe. Whole episodes where most of the GDP went into building cathedrals. Not most, big chunks of the GDP went into building cathedrals. The pyramids, that's praise of royalty. There's less of that today, hardly any of that today. You don't see whole nations investing huge amount of money in the service of God or their king. It just doesn't happen much anymore. So there are two drivers. Two drivers. If you want to do something expensive and it does not fulfill one of those two drivers, it's not going to happen. Period. Unless you're going to claim that you live in a very special community that differs in its outlook on the causes and effects of investment and human dreams. If you have to say that you are different from every civilization that has come before you. I don't see evidence of that. Three drivers. All right, I'm going to get back to those in a moment. This new caucus that was established, Science and National Labs. Most people never heard of national labs. No offense here, but I think I'm right. All right, what is a national lab? You've probably heard of a few of them. Their names kind of resonate in the 20th century history books. Brookhaven Lab, Lawrence Livermore Labs, Stanford Linear Accelerator. You know, you get these places and you knew some big physics was going on there. It is a community of centers where big research takes place. A lot of them owed their birth to sort of 20th century sort of military. It was like we knew that physicists are experts in matter, motion, and energy. And war is about putting energy that is here, there. That's all it is, okay? If there's a target, you don't want that target to exist anymore, you take the energy that you created here and you put it at the target. That destroys the target. That is war reduced to its most fundamental laws of physics. All right. Well, I understand that. You can build centers because you feel threatened. It was a Cold War. Sure, I understand that. Even though I'm an academic, I understand that. Uh, 1989, peace broke out in Europe. We almost had the largest accelerator in the world. Superconducting super collider. Started construction on it in Texas in the 1980s. It was the next frontier in physics. If you go in a place in energy that no one has been before, you're going to discover something. It's that simple. Because you're stepping where no one has stepped before. That is exploration in the laboratory. So here we are riding a century of American leadership in particle physics. Do you know the periodic table of elements? If I put the national flag on the box according to what nation discovered each element, there's quite a few there. Most of them are Western European nations. America is strongly represented. But you know where we're best represented? Down at the bottom, the heavy elements. After uranium, neptunium, plutonium, we have californium. We have berkelium. All right? If you discover stuff, you get to name it. What a point of pride that was. Continuing in that tradition, the physicists said, let's keep going. 1989 comes around. By the way, you can analyze this in other ways. I'm not going to stop you. But what I'm going to say is that when peace broke out, it became harder for people to justify, particularly those writing the checks, why you'd be spending this much money on physics anymore. The Soviet Union was gone. Budget got cut to zero. And that knocked out the frontier of particle physics in America. Well, interesting thing about science is that it continues anywhere else in the world. You don't have a monopoly on it. So CERN, this center, that's the French spelling of the European Center for Nuclear Research. But I'm told that in French it spells the word CERN. The Centre Européen Recherche Nucléaire, something like that. Anyhow, they built the Large Hadron Collider, the most powerful particle accelerator in the world, and they discovered the Higgs boson. Page one story. Even here. We had American scientists there, by the way, and they're actually significant scientific contributions from scientists based, in fact, at Fermilab, who contributed to that discovery. But that fact got lost. The American contribution to that discovery got lost in the news cycle because it got discovered on European soil. So it just didn't, it's hard to take pride in something that someone else announces in another country. What they discovered was the Higgs boson. You know what that is? It's got a weird name. You know, the Higgs, it's a particle that grants mass. It's a particle whose field grants mass to other particles. In fact, it's been colloquially called the God particle. Because if you hand out mass, you're in charge, all right, of the particle physics. You're like, you're the one. And so the way it hands out mass, I give an analogy. I've heard this given, but I think I've improved on the analogy, but the origin of this example I don't take credit for. If you think of a party in Los Angeles, not in the East Coast, West Coast, Los Angeles party, and it's very crowded, and a really famous person walks into the party. So what happens? Everybody crowds around the famous person. So the famous person then cannot move very quickly through that party. No matter what they're sluggish through that party. They have a very high party mass. And if you're a nobody, by Hollywood standards, then no one will crowd around you and you could just walk freely through the party, unhindered. You have a low party mass. So the Higgs field is like a party in Los Angeles. You either have a high party mass or low party mass. And this is the interaction of the Higgs field with other particles. It's an important discovery. Nobel Prize will probably be given for it. We would have discovered that particle 20 years ago. Our accelerator was 3 times the power of that one. So that would have come out first day. Okay? Turn on the switch, pop, there it is. Higgs boson for you. All right, like a vending machine. Now, why do I mention this? Well, war isn't the only driver. Economics is too. It's a huge driver. If we have a suite of centers that previously were in the service of defending the country in some way, because you hire physicists, and physicist is the physics of nuclei that led to the bomb that leads to advanced weaponry, I understand that. But economics matters too. Imagine if you took this suite of national labs and said, the country has needs. We want to engage in projects that are too big for a university. University is like a professor and maybe a lab. Some things require the government, and it's not immediately lucrative to do it. So corporations, their R&D can't justify it. There's this zone that can only be touched by the government dollar if the government cares about its future. Look at the problems that energy and battery technology and nanotechnology and biofuels and maglev, and you just go down the list. I want a country where you have a lab system where you walk by to say, oh, they're working on solving this problem that still befalls us. That'll feel good. Then you've created the country worth defending. And we're not waiting around for some other country to come up with our solutions. By the way, you can't say, okay, I want a more efficient transportation system and I need it in a year and a half. Okay, the engineers will work hard. But somewhere in there you need the scientists doing the basic research. The kind of research that a corporation can't really justify, because they've got the quarterly report, they've got the shareholders, and they're looking for the return, and if the return is 40 years from now, they're not investing. But the country is here forever. Or at least in our minds, we want it to be here forever. So somebody's got to make the investment that goes longer than the time scale of the corporation. So you have the engineers working on the new physics, the new sciences, but you need the science as well. What are some examples of this? In the 1700s, we started to study the concept of heat, energy. In the days of Isaac Newton, my man Isaac Newton, 1600s, the concept of energy was not formulated scientifically. It was not well understood. It would take another century. Then you get like a steam engine, and you start figuring out how to convert energy from one form into another. Mechanical energy, chemical energy, energy of gravity, gravitational potential, and all these forms of energy can be converted into one another with the right machine. Thus was born the Industrial Revolution. And the nations that embraced the Industrial Revolution led the world in every metric that mattered in civilization, mattered to a civilization. So what would next happen? Middle 1800s, Michael Faraday, playing with electricity on a tabletop. He takes a wire and moves it through a magnetic field, and a dial jumps that the wire is connected to. Well, if you do this over here and something else happens over here, that's really intriguing to a physicist. Almost like a cat, looking at the laser beam on the floor. You know, the physicist is, you know, it's kind of like a, and people said, Michael, his name is Michael Faraday, what are you doing? What are you wasting government money for? He has a famous reply to that. He said, sir, because I think it was a member of parliament who came and asked, is this what we're paying you to do, to make these tabletop toys? He says, I don't know of what use this will one day be, but I guarantee you, sir, one day you will tax it. Passing the wire through a magnetic field is how we generate electricity today. It is the foundation of all generators. Turbines. Anything that turns creates electricity and something else makes it turn. You're moving wires through magnetic fields. That was in the mid-1800s. We didn't electrify cities until turn of the century, the early 1900s. It took 50 years for his tabletop experiments in the hands of clever engineers and technologists to transform the world and how we lived. Now you just flick a switch on the wall, all the lights turn on. What intrigues me is that so respectful of that era we are, that our lights even look like candles, you see? So in the back, we still have look at that, right? This is the 21st century, you know, and I know this is an old building, but you can buy candelabras with electric candle bulbs in them, right? So, but it took about 50 years. You know what happened in the 1920s? Other than Hubble discovering Hubble the man, there was a guy who came before the telescope, just so we understand. In the 1920s, Hubble discovered that the Milky Way is not the only galaxy in the universe, but billions more, and that the universe is expanding. Cool. But that's not why I'm telling you about the 1920s. The 1920s was the birth of quantum physics. You can't get crazier than quantum physics. Oh my gosh. Particles pop in and out of existence. You try to measure it and it's not there anymore, but you saw it there a moment ago. And it was intriguing. Once again, it was the physicist following, you know, the bouncing ball. Weird, crazy things were going on inside the atom. Weird things. It's a curiosity. Enlightened nations funded that research. That's the 1920s. 50 years later, we would see the birth of the information technology revolution. Do you realize that, like, the last time I did a back of the envelope calculation, it was something like a third of the world economy is based on knowledge of quantum physics, because information technology requires quantum physics. In the design, in the creation of data, in the acquisition, the storage, the dissemination of information. That's why it's the IT revolution. It's not a computer revolution. Computers is there. It's all about what we're doing with information. It's no longer on a printed page, here's the information. No. No. I was on the airplane yesterday, and I got a note from a program installed on my father's computer that he's running out of disk space. I then sent an email to my sister's husband, said, check out my father's computer, something's dumping data onto. He goes and checks it out. Oh, there's a program run awry. We fixed it, everything's fine. I said, fine. And I did that while flying 200 miles in distance at 31,000 feet up. That's information moving that requires quantum physics. That was basic science, which at the time, surely there were people who say, what are you doing? I don't understand it. Why? Is that putting food on my plate? Is there some new weapon I can use to defend myself? People were surely asking these questions of quantum physics. But we had people who were curious about the nature of the world, and they pursued it, and they were allowed to by enlightened governments. And now, no part of the modern economy isn't touched by the fruits of the investment that went into those discoveries. This goes on and on and on and on. By the way, and that time delay was 50 years. Not 2 years. You know what I wonder? Maybe there should be a new law. I know we have too many laws, but a new law where every congressional session, what do you call the unit of 2 years in Congress? That's called something. A session. Terms, every congressional term, you've got to pass a law that enriches, benefits the country on a time scale longer than your reelection time scale. You have to. Wouldn't that be a great law? And that'll say, now we're thinking, I'm not going to be in office then, but I now have to care about tomorrow. Imagine what effect that would have. My physics professor in college, he liked gas clouds between stars. Yeah, okay. Everybody likes gas clouds between stars. He studied the behavior of the nuclei among the atoms in those gas clouds. And he hypothesized that in the presence of a strong magnetic field, that it would deflect radio waves that came by. He discovered the principle of physics called nuclear magnetic resonance as applied to the universe. Then a clever engineer said, wait a minute, if you can find out what kind of atom, because the nucleus is the identity of the atom, if you know what kind of atoms are out there by this method, maybe I can make a machine down here, and I can put you in the machine, and I can find out what kind of atoms are moving around your body. His discovery, which was awarded the Nobel Prize, became the magnetic resonance imager in every major hospital in the land today. Was he thinking about health? No. No. In fact, every machine in a hospital with an on-off switch that is brought into the service of diagnosing the health of your body is based on a principle of physics discovered by a physicist who had no interest in your health. The cross-pollination of the sciences is a fundamental part of what it is to progress in society. I hear people saying, oh, well, last century was the century of the physicist, but this century is the century of the biologist. Okay, shut down all the physicists, and you'll be using the same machines today as you'll be using 100 years from now. Because you're not inventing the machine. You're not an engineer. If you're the biologist, you're not an engineer. You're not inventing a new principle of physics on which you would base the design of a new machine. All of this has to happen. And you can't sit there and say, how is that going to benefit me? We don't know in advance. But every time discoveries have been made, it has benefited us. We've got the track record to demonstrate it. I'm screaming at you, I'm sorry. I'm just getting me started here. October 4th, 1957, what happened? Sputnik gets launched, and we freak out. Some of you are old enough, were like cognizant at the time. We freaked out as a nation. Perhaps justifiably, because it wasn't just a satellite. Yes, it had the nice name Sputnik. You know what that means? It means fellow traveler. Oh, isn't that nice? Fellow traveler. It's just a basketball with sticks sticking out of it. Why should that matter? Sputnik was a hollowed out intercontinental ballistic missile shell. That was a shot across our bow. The Soviet Union had the new high ground. They were flying over our heads, and there was nothing we could do about it. In came the I don't want to die driver. We said, we need me one of those. Let's get one of those. So we created, among other things, NASA. A year and a day later. I'm born the same week that NASA was founded. I feel NASA. We're like together, just moving through life. We're conjoined. Our souls are one. NASA's a civilian space agency, signed into law by an act of Congress. But who were the astronauts? They were military pilots. So wait a minute, if it's a civilian agency, we got military. What's going on here? Of course, NASA is created in reaction to a threat, and money flows like rivers. The war driver is in effect. The war driver. It's not how we remember it. We say, NASA, we explored the moon. We're discoverers. We're Americans. This is what Americans do. We're explorers. In the day, everyone has said, we're going to the moon. Well, Mars is next. Mars is next. No, it's not next. It would be next if you go into space because you're an explorer. If that's why you went into space, Mars would be next. Did I mention exploration as a driver? No. It's not there. It's nowhere. It's way down the list of drivers. It's an insignificant driver. It's in the noise. We go to the moon because we perceive a threat. We go to the moon. Then we find out Russia is not really getting there. Soviet Union is not. We stop going to the moon altogether. And there are people saying, oh, we stopped going because we need leaders and people with charisma like Kennedy. And it's like, no, that's delusional. Well, look at Kennedy's speech. We will put a man on the moon, return him safely to Earth before the decade is out. That was stirring words. Those were stirring words. Given in a joint session of Congress, May 25th, 1961. He had charisma, you'll say. Is charisma on the list of why we did things? No. No. Go to Kennedy Space Center in Florida. There's a bust of Kennedy right at the front entrance, and a granite wall behind it. And chiseled in the wall are those words: we will put a man on the moon and return him safely to Earth. And you just feel, your spine tingles when you read that. You say, wow, that was an era where we really... Go back to his speech. Go back. 2 paragraphs before he said, let's go to the moon, he comments on Yuri Gagarin, who had just come out of orbit safely. The first human mammal in space. He was the 5th living thing in space, by the way, in case you want. I've tweeted this. Just go back, you'll find it. I said, congratulations, Yuri Gagarin, the anniversary of his orbit, the 5th mammal to achieve this feat, is what I said. And people say, oh, I didn't know that. Well, there's a dog, a couple of chimps, there was some lab rats, this sort of thing. And they all survived. Then we send up a human, and the human becomes the hero. But how about Laika, the dog, right? Then, wait, I got a quick aside. There are all these animal rights folks that say, because Laika, there was no plans of bringing Laika back alive. I don't know if you knew that. Did you know that? It's kind of sad, actually. However, Laika was like a street mutt in Moscow. He gets lifted up and gets put into space and dies there. Now he's like the most famous dog ever since Lassie, you know? And the dog was going to die anyway at some point in its life. So I'm thinking, it's the toast of dog heaven now. No regrets there. Sorry, that had nothing to do with. So, what was I saying before I interrupted myself? Thank you. So Kennedy is on the floor of a joint session of Congress. And he says, because 6 weeks earlier, Yuri Gagarin had come in and out of orbit. He says, in the same speech where there's the granite words, he says, if the events of recent weeks, doesn't even mention the guy, if the events of recent weeks are any indication of the impact of this adventure on the minds of men everywhere, then we need to show the world the path of freedom over the path of tyranny. That was the battle cry against communism. That was the war driver. A speech without that in it would have said, oh, that's nice, but we got other real problems here on Earth. We felt threatened. Money flowed like rivers. President George Herbert Walker Bush, 20th anniversary of the Apollo landing. He said, I want to give a speech. I'm not in his head, but I'm imagining some of this was in his head. I want to give a speech like what Kennedy gave, just to get everybody excited. It's the 20th anniversary. It's an auspicious day. I'm going to give the speech on the steps of the National Air and Space Museum. An auspicious day, an auspicious place, an auspicious occasion. He said, let's go back to the moon, onto Mars, and make a space station, and we're going to take on space in a big way. 1989. It got costed out. Johnson Space Center. They said, let's see what this will cost. Let's take about 30 years, and it'll cost $500 billion. It was DOA. Why was it DOA? Wait a minute, you know what NASA's budget is every year? It's about $17, $18 billion. Times 30, that's $500 billion. NASA's getting that money anyway. You can't now tell me you can't afford this plan? If it was getting that money anyway in the flow? You can't. So why was it just DOA? Something else happened in 1989. Peace broke out in Europe. So of course, we don't do it. I'm going to appeal to you in a way that most people don't. I'm going to tell you things other people are not telling you. You get people who are space enthusiasts, let's go into space, it's our destiny, it's our next, great nations do it. And I look at history and I say, no, you don't know what you're talking about. Here's what we got to do. We've known since the Industrial Revolution and earlier that innovation in science and technology, yes, it'll help defend a nation. But when you're not at war, you know what else innovation in science and technology does? It is the engine of tomorrow's economy. The engine. When Einstein wrote down his equation for the stimulated emission of radiation, which is the foundation of the laser, was he thinking to himself, barcodes? This is innovation in science, the applications of his ideas into machines requires the clever engineer, creative investors, and dynamic CEOs turn it into product. Don't ever tell me, why are you studying this? How is it helping me? You know, I don't know how it's going to help you. I have no idea. Neither did Faraday. He just knew you would tax it. Neither did Einstein. Neither did anybody who made great discoveries about our understanding and our relationship to nature. Do you know, who here remembers statistics? The method of least squares to put a line through points? That was discovered by Gauss, a mathematician, who applied it to the orbit of the first ever discovered asteroid. The asteroid went behind the sun, it's in the glare, you can't find it. He says, well, it did this over here, look over here in 4 weeks. There was no methods to figure that out. He invented a new kind of math to do that. He was inspired by space. The stuff NASA does inspires people. Have you looked at the NASA portfolio lately? It's got biologists, chemists, physicists, astrophysicists, structural engineers. We build stuff in space. The International Space Station, the size of a football field, built in 0G. The latest addition to the national labs, the International Space Station, I might add. So, if you have all these scientists, so here's the task. I stand up in front of a class of 8th graders, and I say, who wants to be an aerospace engineer so that you can design an airplane that's 10% more fuel efficient than the one your parents flew? There's some people who will require that of me as I stand up in front of that class. Instead, what I want to say is, who wants to be an aerospace engineer so that you can design the airfoil that will navigate the rarefied atmosphere of Mars? Everybody's standing up. Everybody wants to do that. We're a free country. You can't require people to do anything, but you can inspire them to completely rise to their intellectual and academic potential. Without that carrot, we will wither on the vine. It's not good enough just to have a good science teacher. You need something at the end of that pipeline when you're hatched out of the educational system. Now what do? It's a noble goal to have high-speed internet in the future and you know, public transportation. Sure. But are those the big dreams that get you running to school each morning to want to accomplish? I don't think so. Here's what happens. When science is funded big, all the sciences, by the way, all of them. But there's one in particular that is an actual force of nature, and that is the vision statement of our future in space. That's a force of nature. That stokes the pipeline. It gets people interested in science and all the sciences. And you know something? Even if you're not interested in science, you're interested in science. Let's say you want to become an attorney, but you've been sort of baptized in this grand quest to explore the cosmos. Then you're going to say, hey, I want to study space law. I want to find out who owns the materials on an asteroid, on the moon. Can you homestead there? It's a whole law frontier. Oh, I'm going to be a screenwriter. I like these stories. I'm going to write a story on a mission to Mars or a mission to the asteroid or killer asteroid. When you do that big, everybody becomes a participant in it. Everybody. I brought with me Hewn Collier's magazine. Who remembers that? You have to be over 60 to remember it. Can we get to Mars? Is there life on Mars? 1954. There was already talk about going to the moon, so it took it a step further, because it thought that this was going on because we were just explorers. The V-2 rocket, designed by Wernher von Braun in the Second World War, used against London and other targets, was the first intercontinental ballistic missile. It was the first missile to leave the atmosphere and come back in. Wait a minute, if you're going to go into space, you better study what that technology, after the war ends, if there's any way you're going to go into space, you better study that rocket. That's why every rocket in science fiction stories in the 1950s looked like the V-2. It had fins. It was bullet-shaped. Did you just take a picture of me like this? Okay. So the influence was huge. People's visions of space. The spaceship had fins, and you know what else had fins? Our cars had fins. If you go to the designers, they're not going to say, oh, I did this because rockets have fins. It was in the air. Exploration of space became part of our culture. The first time we ever left Earth was Apollo 8. Doesn't get the attention it deserves relative to Apollo 11. These three astronauts were Men of the Year. 1968, Anders, Borman, and Lovell. They orbited the moon, Apollo 8. They took this picture. I'm almost done here, so I know you got to vote or something. We'll go somewhere. Does that? If you have a healthy science program in your country, you guarantee your economic future. You're innovating. Then you don't have to have arguments about tariff regulations on products. You don't have to worry about jobs going overseas because they don't know how to do it yet, because you just invented it. I can't stand it when I hear these discussions about our job force. I have to close my ears. Yeah, you can put up some tariffs. Yes, you can complain about them paying their workers less. Sure. Okay. But as long as you understand why you're in that situation, it's because you've stopped innovating and everybody else has caught up with you, and if you have a global economy, it's the job of the corporation to make it for as cheap as possible, so they're going to make it overseas. That's what they're going to do. It's incumbent upon them to do so. But if you keep innovating, the stuff stays here, the jobs stay here. You don't even need to have tariffs because there's nothing to tariff. You assure the economic stability of your future. So when I hear people say, oh, we can't afford NASA, we can't afford it, we can't, it's like, you can't afford not to. Otherwise, you're putting Band-Aids on all your problems. Do I have this here? This is my wallet. Hang on. So, I would do this, but they wouldn't let me carry my scissors on the airplane. You can take $1, okay, and cut off this edge, but don't get into the ink, okay? Then cut off the other edge, but don't get into the ink. Those two amounts of this $1, that's the R&D budget of the United States. And the rest is everyone complaining that our economy is losing ground in the world. Your urge is to get the solution. Your urge is almost never, let's invest in something that will pay off in 50 years. Do you know the culture that ensued in the 1960s? The World's Fair was all about tomorrow. We were going into space. We knew we needed scientists and engineers and mathematicians. They're the folks who dream up a new tomorrow. That's how that works. The World's Fair didn't create the 1960s. The 1960s created the World's Fair. And there's the 1960s, the most turbulent decade in American history since the Civil War. Assassinations, the Civil Rights Movement, a hot war in Southeast Asia, a Cold War with Russia. Yet we found time to go to the moon, motivated by war, for sure. But our economy was pumped. The GDP per capita from 1950 to 1960 made the highest jump across a decade than it has since then. The change in GDP per capita has been dropping ever since the 1960s. What, nobody notices that? Oh, they overanalyze. Well, GDP, well, we got to fund this factory and this thing, and everybody's trying to microanalyze it, yet there's an elephant standing there in front of you. Not only did it stoke our economy, there's something else that it did. There's something else. See this photograph? It's the most recognizable photograph ever. Earthrise over the lunar surface. Taken in 1968 by Apollo 8. 1968, the bloodiest year in the most turbulent decade since the Civil War, this photo was published. Do you realize that until that photo was published, nobody thought to draw Earth with clouds on it? Every representation of the Earth before that photo was just Earth. That's kind of interesting. We didn't think clouds were part of us. That's not Earth, those are clouds. In 1962, Rachel Carson published Silent Spring, which was many environmentalists credit that book for starting the environmentalist movement. They're wrong. Plain and simple, they're wrong. You can do a Google search on words, the frequency of words used in all published books in any given interval of year. And you can ask, what's the frequency of the word environment? That's a word that would show up if you care about it. And let's watch the frequency of that word across 1960. It was a best-selling book. It makes a little bump and then comes back down again. When that photo was published, the word environment, the usage of the word environment triples in published literature. When that photo was published. By the way, Earth does not rise on the moon. The moon always shows the same face to Earth. So the Earth is just simply always there. So it's misnamed Earthrise. It's easy to want to believe that Earth rises on the moon the way the moon rises on Earth. That's just false. It was rising because they're in orbit around the moon. And when you orbit something, stuff rises that wouldn't otherwise do so. Just a disclaimer there. This gets published. It's the first mission to leave low Earth orbit. A year later, Apollo 11, they land and walk on the moon. Steve Jobs is 14 years old. Bill Gates is 13 years old. Just an FYI. ARPANET begins 1969. So what else happens now that we see this moon and Earth rising above it? Here's the list. You ready? 1970, a Comprehensive Clean Air Act is passed by Congress, December 1970. The first Earth Day in San Francisco on the spring equinox, 1970. The first National Earth Day, April 1970. The Environmental Protection Agency is formed in 1970. We are still at war in Vietnam. Students are getting shot on campuses. There's no accounting for this, except that photo. You might remember the Hellstrom Chronicle. It was a pseudo-documentary movie that talked about insects going out of control. from overuse of pesticides. There's an organization founded in Switzerland in 1971 called Doctors Without Borders. Where'd they get that phrasing from? When we saw this moon rising, we saw Earth rising over the moon, Earth revealed it to us as nature had intended. Not as a color-coded map designating nations and states, but of oceans and land and clouds. There are no borders. You look at that picture. Without that picture, they would have said, oh, international doctors, referencing nations. This picture references no nations at all. By the way, if you ask any one of these people, they'll say, oh, it just felt like the right word. Oh, it just made sense. Space was in our culture so deep that you just think stuff up and you think that you just thought it up. DDT, a big issue in Rachel Carson's book in 1962, it was not banned until 1972. We're still going to the moon. The whole Earth catalog uses this photo as its cover, thinking of Earth as a whole, not Earth as an assembly of nations. The Comprehensive Endangered Species Act, December 1973. The first catalytic converter for cars, 1973. Unleaded emission standards were established, 1973. Why didn't all that happen 10 years earlier? 5 years earlier? It happened after that, and it started immediately. Our culture transformed. There we were saying, we're going to explore the moon. Yes, driven by military money. It stoked our economy. We're going to explore the moon. We got to the moon, and we looked at Earth for the first time. It established a cosmic perspective that completely transformed who we are, how we relate to one another, and how we think about our future. So I submit to you that what a lesson this was. We embarked on an activity that was driven by military motives. And out the other side came economic gain and a new perspective on who we are in this universe. Turns out you don't need the military motives. Once you know there's an economic driver, that's a good driver too, history shows. So all it takes is a little bit of foresight. Be a little less parochial, not only in region, but in time. And this nation can rise up and become again what I remembered it to be and perhaps had taken for granted of what it was. Because if we don't act, we're just standing still, and the act of standing still is the same as moving backwards when everyone else is in motion, all around us, around the world. So it's an economic battle cry, if you will. I don't doubt our military resolutions. If China said they want to put military bases on Mars, we're there 10 months later. We're so there, all right? They could probably pull that one off because Mars is already red, you know, so the marketing of that would be easy for them. But I want to go to China just to tell them to leak a memo. They want to put and then we just would go for it. So it just takes a few extra steps to see the economic drivers that are at work here. You are pumping into your society people whose ingenuity creates new economies. It's got nothing to do with spin-offs. Yeah, we all like the spin-offs. LASIK surgery and cordless power tools all came from NASA. Grooved pavements in the road so you don't roll your car on a turn. That all came from NASA. But that's not the biggest thing that comes from research. NASA is like the poster child for discovery and what it can do for a nation. Because no one ever stood up in school and said, when I grew up, I want to be an NIH researcher. It just does, they don't do that, right? So you need the poster, explore, discover. And then the lawmakers will know, if you do that, you pump our economy. The kids will do it because it's fun. They want to stay kids the rest of their lives, as I have. And we will rejuvenate the nation with that ambition. And we can enter the 21st century as the leaders we were coming into it. And that's my message for you today. Thank you. Thank you. Thank you, sir. Thank you. I think I went a little long, and I'm sorry about that, but I have a little bit of time. I'll write you a hall pass if you have to get back to your job. I want to take questions from you, and because that's my favorite part, because pretty much I already knew what I was going to say. So just raise your hand. But thanks for coming if you have to go and get back to solving the problems of the world. A question? Yes, sir. I'll repeat it if you can't hear it. Go. Yeah. We got a microphone.
Okay. Thank you. I was wondering how far away you think we are from an industrial application of fusion power.
How far are we from an industrial application of fusion power? Fusion is the most common production of source of produced energy in the universe. We can make fusion too. We're really good at it. It's called a bomb, right? And so the whole challenge here is to control the fusion, not the simple act of getting fusion. So applications of fusion, what you're really asking there is, when will we have applications, not to put a question in your mouth, but I don't care that fusion is the bringing together of atomic nuclei. I care that fusion is a source of energy for us. So the real question is, what are the prospects for other sources of energy in the world in the future? That's really the question there. And fusion is a contender. Solar power, I tweeted yesterday, I'd be embarrassed to show an alien that we kill each other to extract energy sources beneath the sands when the universe is full of limitless amounts of starlight. And, by the way, someone once, reading my tweets, someone asked, when I compose my tweets, am I high? So it was weird. One time I was distracted by a doily, and I was concerned that not enough people paused to reflect on the beauty and majesty of a doily. Right? Just think about what a doily is, and it's just to sit under your cup. And so I got to tweet something about that now. Hang on a sec. Let me do this. Just be a moment. That's right, because I'd already started. So my response will be to those who ask, am I high? Knowing that the sky sits above the entire earth. That should tell you that the study of the universe is itself a state of natural high. Tweet. Okay. There's no service here, so it'll go out in an hour. Another question. We can get through. Yes, sir, on the corner, on the side.
Do you think there has been a decrease in funding in NASA progressively? There's been a decrease in funding in NASA progressively, and then other companies private companies take up the slack in that. Do you think that will hinder or help NASA in the long run, that other private companies are trying to take the place of NASA?
Thanks. There's like 4 different things going on in that very simple question. And I want to separate the variables, as we say in math, and I'm going to hit them one at a time. The relationship between NASA and private industry has been around since the beginning. Grumman on Long Island made the LEM, the Lunar Excursion Module. It's still a point of pride. You walk down the streets, the engineers from that era are still talking about it. Anybody who was a participant in that era, forgetting that it was completely driven by war, were nonetheless enchanted by the fact that we were going to the moon. So there's always been private enterprise participating in NASA's needs. That's not a new thing. The difference is, will NASA have the private enterprise as a link between where they are and where they need to go? They got to get to the space station. To use a shuttle or let someone else take you there? That should have been happening 20 years ago. Does the post office have its own airplanes? No. You rent space on the belly of a commercial carrier, put the mail on there, and it gets you there faster, cheaper, better, with the efficiencies of private enterprise. NASA knows how to get to low Earth orbit. It is not a space frontier. Save NASA for frontier work. And by all means, farm out the routine parts of what it is you need to do. By all means. Should have happened long ago. Here's the difference. Private enterprise will never lead a space frontier. And I've gotten into arguments with people about this, and then they walked away because they didn't want that to be true, except it is fundamentally true. Space is large. It's dangerous. And if it's space we've never been before, the frontier, the risks are unquantified. When those factors converge, you cannot create a capital market valuation of that activity. There are no investors. Oh, let's go someplace, you might die, we don't know if you're going to come back, we don't know how much it'll cost, and we don't know your risk. Give me your money now. That's not how capitalism works, okay? So the people who take the risks are governments. Governments. The first Europeans to the New World were government funded. Columbus drew the maps, checked the trade winds, found out who are the nice Indians and the bad Indians, and is there food over there, and what are the safe routes and the harmful routes. He brings that back, that gets disseminated, then the Dutch East India Trading Company comes in behind them. There is no case in the history of commerce where corporations, capitalized by investors, did something that was hugely expensive and dangerous and unquantified risks. So, by the way, there are a couple of companies, one recently announced, that want to mine and exploit asteroids. We've been to asteroids. We know how to do that. It's an engineering frontier to figure out how to scoop it up and bring it and exploit it and use it and take it to the moon, bring it back to Earth. Sure. That's within the investive latitude of a company to attract interested venture capitalists. Sure. But if we had never been to an asteroid before, no. No. Newt Gingrich even made that mistake when he said, give the money we've given to NASA to the private industry, we would have had colonies on the moon, on Mars by now. No. Well, yeah, sure, if you pay someone, but then it's not a business model. Yeah, it could be a vanity project. Go get Bill Gates. Bill, take us to Mars. He could do it. It's private money. It's not a business model. He's not making money doing that. Sure, you can just spend the money and do it. But if you wanted to turn a space program into a space industry, there's got to be some return on that investment. And that has historically been the role of governments. So you can't have one without the other. More power to all these companies that want to participate. I foresee the day when the entire solar system is just our backyard. And whatever nobody's done before, that's what NASA's doing. Yes, on the side. That's what you think. Did you hear what he just said? No. He said, I don't need a mic. Now you can hear him, yes.
Among the things that I would think would be a leading driver towards I don't want to die is being hit by an asteroid, being hit by a comet, being hit by
Being hit by an asteroid counts as I don't want to die, yes.
Yes. And yet...
No, that one's I don't want my species to go extinct. Yeah, that's a good one, yeah.
And yet, somewhat inexplicably, you keep seeing proposals for asteroid defense research, asteroid defense programs not getting the funding they want, and I was wondering if you might have an idea as to why.
Because the election cycle is shorter than the asteroid impact cycle. Why would you spend money in your electoral, why would you spend your session's dollars on something that doesn't affect your session? So it's a cultural short-sightedness. But I have a better solution. Oh, by the way, there's a great comic where one dinosaur is saying to the other, now is the time to invest in an asteroid deflection system. So I have a better solution. Your space activities are not simply, what do we do now? Oh, let's all go to Mars. Okay, what next? Oh, let's go to Venus. No. That's not an exploration program. Those are one-offs. The moon was a one-off. What you need to do is have a suite of vehicles. That's my suggestion here. We got the engineers to make this real. You get a suite of launch vehicles that can be combined in different ways, different strap-on solid boosters, liquid, whatever is the combination, so that I can walk up and say, today I want to go to the backside of the moon. Oh, there's 3 of these rockets, 2 of those, 4 of these will launch in a week. I want to do science on Mars. Oh, that's these 3 rockets and this, and you need this life support system because you're not coming back for 3 years, and fine. The military says, well, this new cislunar space, it's the new high ground, but the space between Earth and the moon's orbit. We need to set up some laser tracking places in sort of trailing orbit to the moon around the Earth. Okay, that's this satellite, this launch pad, and this. Oh, there's an asteroid coming. Oh, check with the mining guys. They have ways of tugging an asteroid from one location to the other because they've done it to bring the rare elements, the rare earth elements, to, by the way, elements that are called rare earth are common elsewhere, okay? They're just rare on Earth. They're asteroids where they're common. And so then you phone up the guys and say, we got a new orbit on asteroid 2782. It's going to hit Earth in 37 years. Can you deflect it a few centimeters? That'll buy us another 50 years, and we'll worry about it then. That's the spacefaring future that I foresee that we don't yet have, and we're far from it. Yes? Oh, thank you. I have a radio program called StarTalk. It's kind of irreverent, but we're just really having fun with science, so thanks for the plug. Yes, okay.
I try. What direction would you personally like to see the House Science and National Labs Caucus go in the realm of physics?
Yeah, so I think, I'm partial to physics because there is no understanding of chemistry without physics, and there is no understanding of biology without chemistry. So every century is a physics century as far as I see it, because the rest of the sciences derive their greatest discoveries from it. So you got to fund them all. And I see the labs, which have historically been physics, why not bring them to bear on all the nation's grand challenges that befall us? And when we're not at war, that gives you the opportunity to solve other kinds of problems. But you need the cadre of scientists there just studying the limits of our knowledge. And you want to be able to transfer the freshly discovered knowledge into product. So you want to develop a community of technologists who say, wait a minute. You need those folk. Plus you need folks who visit one center to the next. If I had an oven with coal, like a Franklin stove, which runs on wood, and I say, I give you no, too much. I'll give you $1 million. Make me a better stove. And you're an expert in heat transfer and thermodynamics, and you know you're good. All right? And so you design an oven that's insulated and is temperature controlled and self-regulating. No matter how much time I give you, and no matter how much money I give you, you will never invent a microwave oven. Because that came from military research and communications with microwaves. And we kind of stumbled on the effect of microwaves on food, because water is a major ingredient of food, and microwaves tickle the water molecule, rendering it hot. And then someone said, hey, if it does that to water, it'll do that to my food. Let's make a cavity and call it a microwave oven. Somebody's got to waltz among the camps. Someone clever and ambitious, and maybe has a nose for profit. That always helps as well. The second biggest driver ever. The I don't want to die poor driver. Oh, you have a question?
Hi.
Hello, how old are you?
8.
You're 8. That is such a cool age to be. You know, when I was 9, that's when I discovered the universe. But you're here already, so you've already discovered something. I like your shirt.
Thank you.
Okay, so what's your question?
Well, the question before the last question answer gave me a question. So if the asteroid's coming at us, why don't we try to fling it into orbit around the Earth, like the moon?
Yeah, so you want to save the world. Is what, you know, that's really a good thing to want to do. Well, there are people out there who, see, here in America, we're really good at blowing stuff up, okay? And we're less good at knowing where the pieces land afterwards. So yeah, we've got some leftover missiles, and we could try to destroy the asteroid, right? So that would be, let's blow the sucker out of the sky. You know, that's the macho, that's the testosterone way to do it. But a kindler, gentler way would be exactly what you said, to deflect it. It's still there. It could harm you another day, but to deflect it takes so much less energy. And you could test it to see if you have succeeded. There are plans on paper, which means we know how to do it, we think, but no one has given us money to build the spacecraft to actually do it. So here's what will happen. The asteroid will come. It's too late to vote money to create the spacecraft, and then we all go extinct holding the piece of paper saying how we would have, the paper is like sticking up above the ground. And I don't want to be the laughing stock of the galaxy with all the aliens looking to Earth and say, those stupid humans, they had opposable thumbs, they had a space program, but they didn't deflect the asteroids, which makes us no better than the proverbially pea-brained dinosaurs who came before us, who themselves did not deflect that asteroid because, of course, they had pea brains. So it's a great idea, and you're the right age, so that if one comes around, I want you to save the world, okay? And then they make movies about you, and you'll be a hero. You're already a hero for asking that question that no one else in this room thought to ask. You gotta watch out when you ask questions around adults. Now, you can embarrass some grown-ups that way. But don't worry about it. Okay, they need to be embarrassed much more often than they are. Another question right here, sir.
When you did the interview...
Wait, you began that sentence with an
I apologize.
This is Washington, D.C. We are educated people.
I'm nervous. I apologize.
Okay. Okay.
You gave an interview with the New York Times a while ago where you were asked about the most astounding fact. Is that still the most astounding fact, or has Higgs boson changed that?
Yeah, thanks for asking about that. A reporter came to my office in New York and asked me 10 questions, the last of which was, what's the most astounding fact that I know? And so there it lived, you know, on the internet for years. And somebody took my answer, then somebody decided they liked the answer, and they took it and made a YouTube video of it with some exciting visuals to match my words. The video went viral. It's like got a couple, you know, it's not as viral as the kitten falling off the piano, but it's as viral as any science video that I've seen has gotten. And I invite you to check, just look Tyson and astounding. That ought to land you right on it. They asked, what is the most astounding fact that I know? And I just went off on it, and I will not tell you the answer now. I know you. So many of you have seen it. You must have, because it's went viral. But yes, that's still my most astounding fact. Sorry about the rest of you, Ken. Yeah, I think it's rising through 2 million views, and I was 4 million views. So I'm very moved by that fact. It means there is an untapped hunger that my activities serve, because that's what I am. I'm a servant of the public appetite for the universe. And occasionally I might awaken an appetite you didn't know you had, but really I'm just a servant, showing you the universe that's already there. Yeah. Yes?
Hi. You are obviously exemplary in your ability to communicate science and science stuff to non-scientists. How, in your opinion, would it best, how can we best inspire other scientists to follow in your example?
Wow. The problem is our community is not rewarded by their ability to communicate with people who don't already know their vocabulary and their jargon. There's no return to the community on that. And for the longest while, you were looked down upon. In fact, there's blood on the tracks from Carl Sagan's era for the fact that he reached out to the public. When he appeared on Johnny Carson, what? A scientist on TV, on entertainment television, not just on a documentary, and exchanging jokes with a comedian? And so we've come a long way since then, especially my field, astrophysics, in no small measure because of the efforts of Carl Sagan. So I can stand here and do this, and I can host a radio show with comedians, and we crack jokes all the time. They're scientifically literate jokes, but we're just slapped with, and I can still be invited to Caltech and give a seminar, or to MIT and meet with their advisors. So my field has reached that level of, I would call it, political and cultural maturity. There are other fields that have not. I've seen it. Many branches of physics, that is not the case. Geology, that's not the case. And so, more evidence that I think we're pretty good at this is go to the bookstore and go to the science section. Most of the science books, not including health and human health and nutrition, most of the science books are universe books. And you can tell because all the bindings are dark, because it's some cosmic photo, some Hubble photo on the jacket. So I think we're doing pretty good, and I'm a cog in a very big wheel. And by the way, the State University of New York at Stony Brook, Long Island, just created a new branch of itself to train science professionals to communicate science. So the trend line, the vectors are in the right direction and have the right slope, I think. But it's hard, and to change a culture always takes effort. And so I'm not as pessimistic as you are, perhaps. Okay, that was a 2 thumbs up. Yes, the back row there.
how did you, sorry, how did you...
Let's start the question again.
Sorry. So besides being clever enough to be born after Carl Sagan and choose astrophysics that was culturally ready for your skills, how did you develop those skills? And what advice do you have for other scientists who want to follow in your footsteps?
I think being socialized matters. You got to just know how to have a conversation with somebody. And many other academic branches do. You know, literature majors and history majors and all the majors that lead to you becoming an attorney, for example. You need social skills to communicate your ideas, to argue, to... So I don't think it takes much. You just have to be able to talk to somebody and not put them asleep. And then you grow that audience from 1 to 5 to 10. And it's not a matter of, are you afraid that someone in the audience knows more than you do? If you come from academia, you know more than everybody in the audience. That's a given. All right? So it's really a social force here, not some other kind of anxiety. And I think I've been socialized my whole life. My father was a sociologist, was active in the civil rights movement in New York under Mayor Lindsay. My mother was a housewife, went back to school, became a gerontologist. So I was their like nerd kid, their astro nerd kid, but every time I came home, I understood what it meant to be sociable and to interact with other people. So it's quite natural for me to take what I love, the universe, and just talk about it. It's not an extra effort. It's a natural effort. It's like asking, what does your living room look like? Well, I got a couch here and a picture there and an area rug here. What does the universe look like? Well, it's big and it's 13.10 billion. It's my living room. And I'm sharing it. So I don't think the challenge is as hard as people think. Now, it is a little different. I do some things that I don't expect anybody else, like my Twitter stream. It's just completely weird stuff in there sometimes. And it's just weird. Other things I do, on my radio show, I am cavorting with comedians. Well, that's because I happen to be deeply respectful of the comedic arts. Deeply. I think they carry the soul of our culture in their banter. And so I'm very comfortable in the presence of witty comedians who are sharp, clever, and even barbed. When I give lectures, have a handheld microphone because they have handheld microphones. You know why? Because, for example, if I were describing the next asteroid that may render the west coast of the United States, may obliterate the asteroid Apophis, I get to say it like this. Apophis is named for the Egyptian god of death and darkness. I get to do that with my microphone. If it's a lavalier, I gotta go, and you can't. Little things like that. Yes, so you learn those, and I've developed those over the years. And it allows me to have a radio show where I talk to comedians, and I have as guests actors, politicians, authors. I don't have scientists on my radio show. You know why? Because there are people who will not listen to a radio show if it has a scientist on it. So I turn the table around and say, I'm the host and I'm the scientist, and you're going to follow your favorite person to that show. You're a fan of that politician, of that actor, of that writer, of that comedian. And you know something? That person is going to have a conversation about science with me. Their fan base follows them to that program. I don't expect everybody to do that. That's a lot of effort for me to pull that off. But just talking about your research that's tax-based funded, if you resist that, I don't know that you even have a right to be a scientist. It's your obligation, it's your duty. And if you're not that fluent, socially fluent, then create a website. Write an op-ed. There are lots of ways to intersect the public, and right now, hardly any of them are rewarded in the field. So yeah, I work at it when I'm called to. Otherwise, I'd rather just stay home and watch the ball game. I'm perfectly happy there, by the way. Let me take one last question, and then we'll wrap it, okay? Right here in the middle, yes. You started with an again.
One of the things that I'm aware that you're doing that I think is great for getting the public interested in science is working with the GZA on his album about space. Can you tell us about what's going on with that?
Okay, actually, the Wall Street Journal got the story wrong. I'm not collaborating with him at all. Next question. No, well, no, I do want another question because that was not, she was misinformed. I had the GZA, who is a rap star, a hip-hop artist, on StarTalk Radio. Why? Because his next album, the lyrics on his next album are inspired by cosmic themes. He's rapping about the Big Bang and the expanding universe and gravity and dark matter and dark energy. You know a subject has been embraced by pop culture when artists take ownership of it. When that happens, you become in the mainstream of thought. You're in the culture. And so that was one of our more successful episodes of StarTalk Radio. A rap star. What's the stereotype? Oh, the gun shootouts at rap concerts, right? And here's somebody who's actually making a difference with his rap lyrics. And I didn't let that go unnoticed on my show. So no, but we're not collaborating. But if he calls me up and said, you know, I need a word here, you know, I got cosmic word, I can hook him up. You know, we got vocabulary. Good vocabulary, too. None of this stuff like geologists. Well, this is orthoclase feldspar. No, I can't rhyme that. I'm sorry. Oh, this is deoxyribonucleic acid. Can't rhyme that either. Big Bang, black hole, quasar, pulsar. Spots on the sun, sunspots. Red spot on the sun, on Jupiter, Jupiter's red spot. We got vocabulary to burn here. I would take one last question, and it better be awesome, because it's the last question. Is it awesome? We'll be the judge of that. Go, sir. And the last question, thank you all for coming after this, yeah.
I'm also a big fan of StarTalk, and a couple of months ago, you had thrown a fact out there about black holes, and that a black hole the size of a quarter could actually devour the Earth-sized planet, an Earth-sized planet.
Oh, easily.
And I've heard you talk about black holes a lot.
Have you not slept well since then?
No, it's not that. It's not that. I would like to know what that would look like. Would our atmosphere be the first thing to go? Would things become oblonged and sucked into it like what you imagine, or would it break apart? Just,
I mean, how do you get something the size of the Earth to fit into something the size of a quarter? Yeah, so I recently a year ago, I tweeted, we have these things called pulsars, which are very dense matter. It's like the densest matter there is before you collapse into a black hole. So to put that in context, how dense this material was, I said, take a herd of 50 million elephants and cram them into a thimble. Then you get the density of the material on a pulsar. So in other words, scoop up a thimble's worth of pulsar material, put it on a scale, on a balance scale, and then I say, what do I have to put on the other side here to balance that thimble? I have to put 50 million elephants here. So that's an extraordinary extreme of nature. In fact, in my field, we have to be parsimonious with our descriptive adjectives. I can't say Jupiter's gigantic. Well, it is compared to Earth, but it's small compared to the sun. I can't say the sun is gigantic. Well, it can hold 1 million Earths if it were hollow, but Betelgeuse can hold 1 million suns. Okay, so when do you say something's big and huge? So I try to, but now we're at the limits and I get to say this is an awesome number of elephants to fit into a thimble, okay? So now you go denser than that, this thing collapses into a black hole, and no matter the size of the black hole, it's going to eat anything that comes near it. So Earth would slowly sort of, what happens if you drop the black hole, Earth and the black hole will drop towards one another, okay? And Earth will begin to funnel down towards it. And so basically, Earth will begin to crumble as it gets ripped apart and it gets stretched, spaghettified. It's the act of spaghettification that occurs because the black hole is small and what it's eating is large. And that's what happens in a spaghetti machine. There's a tiny hole and a big blob of dough, and at the end, it's a spaghetti stream. So it would not be pleasant. It would probably happen very fast, faster than you can communicate this information to the other side of the world. So just enjoy it as it happens. It's a one-way. We're pretty sure we've got the inventory of black holes figured that this is not the most likely way to die. But it'd be an awesome way to die. By the way, this ripping apart into a strand, the two things that are happening is ripping you head to toe, Earth head to toe, and the funneling is another interesting feature because the space-time that it occupies is this tiny little narrow funnel, essentially. And that's where you get, that's the concept of spaghettification. And I wrote a book, Death by Black Hole. Oh, she has the book right behind you, see? Yes, Death. Vanna White, thank you for displaying. And in there, I describe in detail what would happen if you personally fell into a black hole. And yes, it's a one-way trip, but it's awesome, and it's my choice of death. Like if I went death row, I said I want to die by black hole. If I had the choice. But it's much better than getting hit by a bus, right? It's a one-way trip, and you get to do experiments all the way down. Thank you all for your attention. Let's keep it going here. Thank you. Thank you.
Thank you so much, Dr. Tyson, just phenomenal. This was awesome. Thank you all for being here. We do want to encourage you to talk to your members of Congress, people that you know. We'd love to have their help on the caucus. We'd love to have your help on the caucus as well. This is important, and we've got to tell this story. So thanks for being here. Have a great afternoon. Again, Dr. Tyson, thank you. One more round of applause for Dr. Tyson. Thank you.